Hello, everybody. How are you? How are you doing? Today we'll see, let's say, a new lecture. Okay, we explained this in the classroom, but I prefer also to give you a slight idea about this. The Samaran Bilingual School, Department of Math, Exponential Growth and Decay. Okay, so Sunday, it will be Sunday 24 January, okay, till 28 January 2021. Okay, class 10. Teacher Murad Sultan Zwidi, HSM. The title or the topic: exponential growth and decay and compound interest. So remember basic equation first, small learns is y equal a b to the power x. Okay, a is a real number, b is the common ratio. Okay, we can see where a is a starting value, b is the common ratio. Okay, if the ratio is, let's say, less than 1, we can say that it's a exponential decay. If the ratio b, for example, is 6/5 or 7/5, like that, we can say that it's an exponential growth. Okay, exponential growth, increasing, or the mean of exponential growth, my learners, is increasing or goes up in a value. When the constant ratio, the number being raised to a power, this is the number b being raised to a power, is greater than 1, the output y equal a multiplied by this ratio to the power x should increase, and the model is called or is named or is labeled as exponential growth. Example: y equal 2 is the starting value. Okay, it can be 1, and 6/5 to the power x. Okay, 6/5 here is a ratio, but is more than 1. You can say that it's greater than 1 to the power x. This one is called what? It's called, or the value of y, the value of the output is increasing, and this function it's called exponential growth. For the other example, y, the output value equal y equal 0.5 multiply between parentheses 1 plus 0.35 to the power t. T here, number of period of times or number of years or something like that. 0.35 gives 1.35 is increasing, is more than 1. So the ratio b is more than 1. You can say that the output value y will increase, and the model is exponential growth. For the third, let's say, output value y equal 1000 multiplied by 1.5 to the power t. This is also is called the model of exponential growth. Now we see the mean of decay. Exponential decay means decreasing, goes down in the value. Okay, when the constant ratio, this constant ratio b is less than 1, number being raised to a power is less than 1, the output value will decrease, and the model is called the exponential decay. For example, y, the output value is 4 is called the starting value, b is the common ratio here, so it will be 3/4 to the power x. So 3/4 is less than 1, it's 0.75. This one is decreasing, or it's called also exponential decay. The second example deals also with the output value y equal 0.5, which is the starting value, and 1 minus 0.35, it will be 0.65, which is less than 1. It's called the ratio, the common ratio. T is the power or the index here. It denotes number of years, okay, real number, something like that. Okay, so this one also is decreasing. It's called what? The exponential decay. And the third example, the output value y equal 1000 multiplied by 1 minus 0.2 or 0.2 to the power t. This is also is the model of exponential decay. Identify the following as growth or decay. For example, you are thinking the part being raised to a power bigger than 1. So it's as it is bigger than 1 molarness is exponential. It's a growth, means exponential growth. And between 0 and 1 is decay. Between 0 and less than 1, it's a decay. Okay? For example, here, look at the output value equal 500 multiplied by 1.20 to the power 5. Okay? For example, if you invest $5 in the bank with a simple interest rate let's say 20%, okay, during 5 years. So number of years is 5. So it will be principal multiplied by 1 plus the rate all to the power n or t. T or n is the number of years. So it will be 500 multiplied by 1.20 to the power 5, which is exponential growth. You are checking the part being raised to the power. Bigger than 1 is a growth and less than 1 is a decay. This one is a growth. Good girl. Good boy also. So the second example, the output value is 375 multiplied by 0.78 means 1 minus the rate, sample rate interest, yes. So it will be 0.78 to the power t, number of time, number of years. So this one, it's a decay because 0.75 is more than 0 and less than 1. For the second example also, you can see this is a growth simply because the ratio 1.075 is more than 1, so it will be a growth. This one, it will be 0.99 to the power 4, of course, multiplied by the amount of money or the principal or the original amount or principal. It's called principal. So it's a decay because it's less than 1. Remember basic equation is y equal a b to the power x. We told b is the base here, but we call it here as a ratio, and a is starting value, b is the ratio, and x is the index. It can be, let's say, number of years. It can be a real number, okay? Whereas the starting value will be the common ratio. Exponential growth formula. Here we have a formula. You should know about this formula. Y equals c multiplied by 1 plus r to the power t. Okay? So c, we can say that 1 plus r should be more than 1, greater than 1. That's why it's called growth, exponential growth. Okay? For the exponential decay formula, instead of writing plus, make minus, and 1 minus r should be less than 1. You can see that the output value is c multiplied by 1 minus r to the power t. 1 minus r should be less than 1. This is the two formula that you can use in while working with investing money. C here is like a starting value or a principal or the original amount that you can invest in the bank and something like that. 1 plus r or 1 minus r is like b, the common ratio. Example, you buy a new car, a new 10-speed bike for $150. It loses a value at a rate of $15 per year. What is worth in 3 years? Okay, so you will make what? You will make 10 because you buy a new 10-speed bike. Each bike costs 150. You make 10 multiply by what? By the price. Then you will make 1 minus 15%. Okay, in 3 years to the power 3. Here worth is cost. The rate to the power is worth is cost. Okay, the price of these 10-speed bikes multiplied by the rate multiplied by the years. It will be what? C 1 minus 0.15 to the power 3. A loss means 15%. So it will be $150. So you mean that you buy a new 10-speed bike for $150. So the price of this 10 bike is $150. So see, $150 multiplied by 0.85 to the power 3, it's a exponential decay, and the answer, the worth, it equal to 92.12. The bike was only worth 92.12 in 3 years. Write a general equation for the following. You purchase a car for $35,000. The minute you drove it of the lot, it started going down in value by 1.3%. Write an equation for its value in the future. Then you just purchase it, painting as an investment, and it's supposed to appreciate its value at a rate of 3.65 each year. Write an equation for this one. So here we have the first one. I will make f, the function f of t is 35,000 multiplied by what? By 101 minus, or 100% minus 1.3. It will be 0.987 to the power t. Okay, so that's why it's a variable in terms of t. It's written a function in terms of t, but it's a exponential decay. The second one, we have ft equal principal multiplied by 1.0365 to the power t, of course. Okay, this is how can we route, let's say, this the equation of each question. Now compound interest will be an exponential function. Compound interest formula. The compound interest, my learners, is a equal p multiplied by 1 plus r to the power t, and p of t is p0 multiplied by 1 plus r to the power t. E or pt is total amount you have. P or p0, it's called principal amount you started with, and r is the rate of interest, written also in decimal or in percentage, t time in years. Okay, so find the total. Here you have exercise. Find the total amount in your account if you start with 750 at 7.5 interest compound annually for 2.5 years. Here the amount that you will start with is 750 at 7.5 interest rate, means you will make 750 multiplied by 1 plus 7.5 all divided by 100 to the power 2.5. Okay, look here, this is the formula for compound interest. A equal the amount that we get after 2 years and a half, after 3 years, and so on. This is dependence on the number of years in the exercise. Here we have 2.5. So p multiplied by 1 plus r to the power t. Here it will be the principal, or the amount that you start with, 750, 1 plus 0.075 to the power 2.5. Just plug in what you know, and the answer should be 750 multiplied by 1.075 to the power 2.5. Just simplify, use calculator. The answer is $898.63, of course. Another exercise, my learners. Here, this exercise deals with how much should you invest at 7% compounded annually to have $200 after 5 years. Okay, so the rate is, interest is 7%, and to have then $200 after 5 years, you just plug in what you know. The A equal P 1 plus R to the power T. So it will be the amount we told 200 equal P multiplied by 1 plus 7 divided by 100 to be 0.07. It will be 1.07 to the power T. T is 5 years. Then isolate P to make P as a subject. It will be P equal to 100 divided by this amount. Okay, So P equal 200 divided by 1.0.7 to the power 5, and the last answer, the principal that you should put in the bank to investigate, let's say to invest at 7% compound annually to have this amount, $200 after 5 years, is $142.6. Now another exercise, you put $100 in the bank at 4% interest compounded annually, and leave it until you are 60. Write a function to show how much money you will have as a function of time in year and solve. Here the function I will make f of t equal p multiplied by 1 plus r to the power t. So we told the f of 46 to 100 multiplied by 1.04 to the power 46, because 60 years. Okay, then this assumes that you are currently 14. If your age now is 16, you will make 60 minus 16, and you will write the answer here, and you write the number of years. Okay, but we assume that your age is 14, that's why we make 60 minus 14 gives 46. So f of 46 after 46 years, he will get an amount of $607.48. You will have already $607.48 when you are 60. Now another exercise. So what if you put the same $100 in a mutual fund that pays 10 interest compound annually until you are 60? Write a function to show how much money you will have as a function of time in years, and solve. The formula always, you in terms of years, it will be f of t equal p multiplied by 1 plus r, okay, to the power t. It will be we assume that your age is 14, so f 46 years, it will be 100 multiplied by 1.10 to the power 46. It will be $8,017.95. This is the amount that you will get when you are 6 years old. Now compound to simple interest, which will be a linear function. We see the compound interest annually, and now we will try to compare with simple interest. To find the amount of interest you earn, I equal p multiplied by r multiplied by t. Sometimes it's written I equal p multiplied by r multiplied by t divided by 100, because the r is written in percentage or in decimal, as you like. To find the total amount, you have to use the total amount is a, capital A, equal p plus p rt, or equal, and I will explain this, I will label this as p of t, means a function of the simple interest. It will be p0, the original amount, plus p0 multiplied by r multiplied by t. You can see here p0 I will put outside the brackets, will be p0 multiplied by 1 plus rt. So here the I is the interest, A or pt total amount you have, P or p0 principal amount that you start with, R rate of interest, write as percentage or as a decimal, and time is t, time in years. If now in exercise, if you invest $3,000 at 5% for 1 year, how much you will have or will make for this year? So the formula is very easy. I equal PRT. 5% I will write as 0.05, so it will be NP $3,000, and number of years is a single year, 1 year. It will be 3,000 multiplied by 0.05 multiplied by 1 gives 150. This is the interest. But you made 150 for this year. We should add to what? To 3,000. So P1 equal P plus PRT gives, means 3,000 plus 150 gives 3,150. So P1 I will make 3,000 plus 3,000 multiplied by this gives $3,150, of course. you have 3,150 after 1 year. Okay, thank you for listening, my learners. It's Murad Sultan is with you again. I wish that this lecture is clear for you. Okay, stop recording. I will stop.